What is up, guys? Fahir here from AwesomeTunes.com, and welcome to another Unreal Engine C++ course, because we're going to create this game using only C++. And this is a game that I call Gladiator Arena. Basically, we have two gladiators, two chubby dudes like little toddlers fighting, and let me show you the game that we have. So if I hit the play button, here they are. I have my character who doesn't have his weapon and the armor, and our AI is chasing us. So I need to come close over here to pick up the armor and my, well, weapon, and now I can start attacking him. And notice at the top corners we have the health, so if we start fighting each other, you will see that we are subtracting health from each other. And when one hits 0 health, we also have the sound effects, you can see, but it plays on random. So if I kill the enemy, notice the enemy is dead, and now we restart the game and play again from scratch. It looks like a small game, but as you can see, and we're going to learn a lot because everything here is implemented in C++. We also, for the first time, have our AI, and notice how the AI is chasing us, and on random, if he doesn't see us right away, notice he's going to roam in the level. So you see, he doesn't see us currently, and he's searching for us on a random location. So he is going through the level, but when he sees us, he's going to come straight at us, as you can see, and he is going to start attacking us. And same as how we killed him, when our health drops to 0, we are going to die. We're going to play the death animation, and you hear his attack sound like those tennis players. You get the point. And now I'm going to die, and the level is going to be restarted. Again, it looks like a small game, but we're going to learn a lot. First of all, we're going to use AI. We're going to learn about behavior trees, blackboards, all sorts of stuff, how we can implement that in C++, how we can create tasks, so on and so forth. I don't want to stall anymore. I know you are eager, you want to create this game, so let's jump in and create this cool game. So I will see you in the next video. What is up, guys? Fire here from AwesomeTunes.com. Now that we saw the game that we are going to create, those little fat, how I'm gonna call them, gladiators or whatever. So let's get into the project. Open your Unreal project browser. You're gonna click on the tab for the new project, and because it's a C++, you're gonna click on here for the tab on the C++. Click this basic code. We don't want any of these first person, yada yada yada. Just click on that. We don't even need the starter content, so make sure that you don't import it. And over here, you're simply going to, well, set where you are going to save your project. This is the name of your project. I named mine Gladiator Arena. Click on create a project and wait for it to create. And this is what you will see when it finally finishes, because it takes some time for whatever reason, depending on how strong your CP is. Anyways, CP is a personal computer. Anyways, or computer personal. Moving forward, here is everything that we have. So we have the content over here. You know the drill. What I'm going to do is right click here on the content, and we are going to show that in the Explorer. There you go. So here, when you find the project, here is your project wherever you have saved it. You have binaries, you have config, you have all of the good stuff. Now we need the content. So this is what we need. And inside of the content, you are going to import the assets. You will be able to download the assets. Link will be below this video. So right below, or you will see, I don't know, on the side of the video. But anyways, just scroll below, you will see, or on the side, you will see on this video to download the assets, and these are all the assets that you need. You will also be able to download the complete project as well. So I'm going to select all of this over here that we have. So arena, buildings, characters, yada, yada, yada. Simply drag all of that over here. So drag it, wait for it to, well, copy over here. And now we can close this window. We can go back over here in our Unreal Engine. And there you go. Just like that, just like magic, we have everything that we need. Now, here we have our maps, as you can see. So this is our map, and I have already prepared it, because why should I, just show you how to drag and drop this and put it over here, the drill, so on and so forth. You can go over here and inspect some things on your own, because the more you do things on your own, the faster you will learn. I mean, I'm over here to give you guidance, but yeah, the best way to learn is by trying to do this on your own. So if you go here on the meshes, you will find all the good stuff. Anyways, what I want to do over here, and here is your arena. So everything you will find over here, the materials for the arena, and yada, yada, yada. So just go and explore a little bit this project so that you can see and find everything that's inside, and the meshes and the materials and whatnot. And then, well, There you go. So what I want to do, the first thing is start creating over here our classes. And here we have our C++ classes. So I'm going to right click and go here under new C++ class. And I am going to select the character as the parent class because, well, we need a character to move our game character. And I'm going to click on here next. And the name of this class is going to be Arena Character like this. And simply click on create the class and there you go. Now, let us wait a moment or two for Unreal Engine and Visual Studio to take mercy upon us because we're mere mortals and we need to wait for the compilation, or however you want to call it, because it does take a little bit of time. I don't know how this is implemented in terms of communication between Visual Studio and Unreal Engine or Visual Studio Code, but yeah, it takes a little bit of time. Anyways, what I want to do in this video is prepare the classes and also create our character finally. Here it is, finally, thank God. So double click this and it will open over here in Visual Studio. So let me just open my Unreal Engine. There you go. So this is our Arena character, H file and Arena CPP. In the H file, you know that we declare the things that we want to use. And in the CPP, you know that we implement those variables and everything that we have declared in the H file. Now, for the moment, we're not going to touch anything and we're going to go back over here and create another class because the Arena character class is going to be the base class from which we are going to inherit for the AI character as well as for our own character. So I'm going to right click again and new C++ class, but this time I'm not going to filter here for any of these classes. Instead, I'm going to click over here where it says show all classes. So click here to show all classes. And now over here, I'm going to filter for Arena character class. And here it is. This is our custom one that we have created. Click on that. This is going to be our base class. I'm going to click on next. And for this one, this is going to be by player character. And I'm going to click on create class to create it. And there you go. Now, of course, because we are inheriting from the Arena character, we will need to override some things, such as our begin play and so on and so forth, because as you can see here in the .h file, automatically, we just have, you see, the generated body and whatnot. And if I go over here in the Arena, we have the constructor, we have the begin play, we have the tick, and we have the set up player components. So we're going to override these. And in order to override them, we need to come over here and right here below where it says our generated body, I'm going to type here public because I want these to be public classes or actually public methods. So here I'm going to say virtual void begin play like this. And I'm going to say override because we're going to override it from the parent class, that is, so from the parent. Now it's begin, not player, it's begin play. Why did I type begin player? Moving forward, we are also going to have our void or virtual void, excuse me. So virtual void, and this is going to be the tick function. And here I'm going to say float delta time, which is the parameter. And of course, this one is also going to be override. And the last thing I want to override is virtual void. And this one is set up player input component, so component, and inside of it I'm simply going to type class u input component, which is going to be a pointer, and I'm going to call it player input component, and there you go. And over here we simply need to say override. Now we do need to implement all of these. If we don't implement them, then we will have issues, it will complain, and yada yada yada, as you can see over here. So I need to right click on the tick, go here and implement it. As you can see, also right click on set up player input component, quick actions and refactoring, create definition, and it will create the definition automatically for us over here, as you can see. And we're going to do the same thing for our begin play. So it's going to be void a player character, so character colon begin play. There you go, and voila. So there you go. And now if I command or control shift B to compile this, or go under build and click on build solution, on Mac is command shift and B to build this, we will see that build has succeeded. We don't have any errors and we can proceed with our game. Now to wrap this up, this video, I'm gonna go back over here inside of the project and in the content and right click and create a new folder, and I'm going to call this one blueprints, because here is where I'm going to store the blueprints for our game. and we are going to create our game character or our player dwarf. So I'm going to right click, go under the blueprint class and click here, all classes. So we're going to filter all classes. So click there, and in the search, you are going to type player character. You see, player character that inherits from the arena character, that inherits from the character, inherits from the pawn, from the actor, from the object. This is the hierarchy of it. So select the player character, and there you go. And I'm going to call this one player dwarf. So dwarf. There you go. This is our player dwarf. Double click this bad boy and open it over here in our Visual Studio. In the blueprint editor, what am I saying? So first things first, for our mesh over here, we are going to select the mesh of the dwarf. So here, click on the mesh and then go on the details panel, and here it is. So here for the mesh, click on the drop down list, and we are going to select dwarf grunt R. This is our dwarf, and I'm also going to set his Z position. So Z location here for the transform. Set the Z location at -65, not 5, but 65. Why? It didn't count 65. There you go. The Z rotation is going to be -90 because I want him to rotate towards this white arrow, as you can see. You see this white arrow that comes out of his beard? You see this white arrow weird thing? Anyways, I want him to rotate towards that arrow. Simple as that. Now, what I also want to do is select the capsule component, and for the capsule component over here, the capsule half height, we're going to set it at 64, and the radius of the capsule is going to be 50. So this is our little dwarfy. Look how friendly he looks. I am also going to click here on add component. So select here the capsule and click on add component, and we're going to filter for the spring arm component, which is going to hold our camera. Simply rename it or name it spring arm, and for the spring arm we are going to attach the camera. So select it and go under add component and filter for the camera and attach the camera. There you go. So voila, basically this is all there is to it in order to set up our character. I'm also going to select the spring arm component and go over here and set the target arm length to 600, which is going to simply move away the spring arm from my character by 600 units. That's all there is to it. And I'm going to compile and save that. Now, before we finish this video, and I said that I'm going to, before I wrap this video up, we're going to create our player character, but I'm only going to create a game mode. So I'm going to go back over here inside of our classes, and I'm going to right click, new C++ class, and over here show all classes. I'm going to filter for game mode, and we want this one, not game mode base, but game mode, and click on next. And over here, I'm going to call this one arena or gladiator arena underscore game mode, like this, and click on create the class, which will create the class, and I'm going to create a blueprint out of it so that we can do one thing. I'm going to show you that, and we did this in our previous courses in the academy, depending on where we're watching this. So in the academy or in other courses of my Unreal Engine, what I need to do is, because if I go back, why I'm doing this, so if I hit the play button, you see, this is what we see. So what the hell is happening over here? We don't have our player character. Let me just find the player start. So we have one player start and another player start. So I'm going to delete this player start so that this one is the only one that is left in the game. You see this one over here. And if I save the current and hit the play button, you see, this is what we have. And if I eject myself, I click over here to eject myself, this is our player. This weird sphere thing. I don't want that. I want my dwarf to be the player. So I'm going to go back here in the blueprints, and I'm going to right click and blueprint class. And here we're going to filter for gladiator arena game mode. So this is the class that we've just created. So select it. And I'm going to call this one gladiator arena. So arena underscore game mode underscore BP, so that I know that this is a blueprint. And we're going to go into the project settings over here, maps and modes, which is over here. So select the maps and modes. And over here where it says default game mode, as you can see. So over here, we're going to click on the drop down list, and we're going to select the gladiator arena game mode. That allows us, because here we had the default game mode, and I cannot find it now, game mode over here. See, the default game mode was game mode, and here it does not allow us to select the default pawn and all of the good stuff over here. So if we select our own gladiator arena and go over here to default pawn, I can now select my player dwarf, and voila! If I go back now in the desert arena level and click on play, there you go. Look at this. Look at my little gladiator over here. So let me just go here and eject the bad boy. Look at this. So this is my character. You see, he is floating. We will fix this. Do not worry about that. Everything will be fixed. But yeah, this is my game character. He's now being spawned and so on and so forth. So Fire here from AwesomeTunes.com. This was it for this video. We'll continue with our game character from the next video, and I will see you in that next video. Well, else can I see you? See you then. Moving forward with our game now, we are going to create the player's movement, and we are going to start over here inside, and I'm going to close this one because this is created from the previous video. I'm going to start here in the arena character, and what we need to do, so right here below the tick, I am going to create two variables, and they are going to be uProperty, so uProperty, because we need them to be in the blueprint visible. So here I'm going to say blueprint read write, and it's going to be visible anywhere. Now, blueprint read and write means that they will be available for us to manipulate inside of a blueprint, which we will do later on when we start creating the animations of the player. So this variable is going to be bool, b is attacking, so is attacking, and by default I'm going to set that bad boy to be equal to false, and over here I'm going to copy this and paste it, and over here we are going to have b is, so it's lower b is alive, but this one is going to be true because by default we are alive. Now, why do we need this? Well, we will see that in a moment. So we need these two variables to know when we are alive and when we are attacking. So let's move now here inside of the player character. And by the way, this is in the arena character over here in the .h file, because as I said, this is going to be the base class for us to use to manipulate, or actually to also, we're going to inherit from the AI character. So the AI character is going to use this as a base class, as well as our own game character is going to use this as a base class. So basically now we can go back here in the player.h, and right here below, so right here below our player setup input component, player input component, we're going to say protected, and protected basically just means it is only available within the class scope. So inside of this class and inside of the inherited class, and it will not be available outside of this class to use. And if it's not clear, go and watch my C++ tutorial series, which is in the Unreal Engine beginner course inside of the Academy. Now here in the protected, we are going to create void move forward to, of course, move our character forward, and it's going to take a float value, which is, well, the parameter, and I'm also going to copy this bad boy and paste it over here, and this one is going to be move right, and we're also going to control our mouse, so we're going to have void mouse underscore, actually mouse, not move, mouse x, which also takes a float value, so float value like this, and also we're going to have a void mouse underscore y, which also is going to take a float value as a parameter. Now we are going to implement all of these in a moment, because in order to make this work, we do need to go inside of our project settings. So let's go over here and in the project settings, and what we're going to do, and by the way, if you don't see the project settings tab, you're going to click on edit, and there you go. Here it is, project settings. So you're going to go here, and we are going to go where it says input, which is over here where I have drawn this big arrow, and there you go. So we have the action mappings and the axis mappings. Click the plus here to add action mapping, and click here to unfold it, and also here to unfold it. This right here is the name of the action mapping. So the name is going to be a tag. This is what we are going to use in the code. And over here, we're going to bind this attack to which button or what we want to detect. Well, I'm going to go over here in the mouse, and we're going to select our left mouse button, which means when I press the left mouse button, this over here will be triggered, and we will know that in the code. Now here for the axis mapping, click on the plus button, and also for this one, unfold it. And for new axis mapping 0, we are going to change that to move right. So this one is move right, and we are going to use this in the code. And over here, I'm going to go on the keyboard and we are going to select the A key. So let's scroll over here and find the A key and click here. Now this plus button, click this, not this plus button, because this plus button over here will add another key that we will be able to press to detect or actually to trigger this move right axis mapping. So click on here on the plus and let's go over here in the keyboard and scroll down for the D key, and here it is. Now, when we press the D key, we're going to move to the right side. So here we're going to leave 1. But when we press the A key, we're going to move to the left. So over here, we're going to say -1 because the left side is the negative side. Now, click on this plus button to add another axis mapping. This time, we are going to have the move forward. So over here, I'm going to say move forward, and you get the drill. It's the same drill. So click on the plus over here. We're going to have, so let's go over here on the keyboard and we're going to filter for the W key. So here it is. We have the W. And again, click here on the drop down list keyboard and filter for the S keys. Let's just find the S key. There we go. So when we move forward, we're going to leave this at 1 because moving forward is the positive, moving backwards is the negative. So here I'm going to say -1. And let's do 2 more of these. So axis mapping. So the first one, so double click over here and change the name. It's going to be mouse_X. And over here, click on the drop down list, go under mouse and filter for the mouse X. There you go, which is going to detect when we start moving the mouse X left and right. And this one, well, you can assume it's going to be mouse. So mouse_Y. And of course over here, click on to filter. Let's go under mouse and mouse Y. There you go. This is all there is to it. This is everything we need to do in order to make this work. Now, we are going to go back inside of our script and we are going to implement all of these movements. So right click here on move forward, click on quick actions and refactoring and create definition of move forward in player CPP, which will automatically create this for us over here so that we don't have to come over here and type something like this, so that we don't have to do this and paste it. And this one is going to be move forward. The next one is going to be move right. So instead of doing that, we can simply go back over here, right click on this, quick actions and refactoring, create definition, and there you go. Smart, I know. So let's go over here, right click and do that on the Y, and voila, created the definition. So there we are. So this is all there is to it. Now, what we need to do over here inside of our player input component is this is where we're going to bind all of these. Now, before I do that, I'm also going to go here in the begin play. I'm going to call super begin play. And we're going to do the same thing in the tick and in the player input component. So over here, we are going to call super, which is simply going to call this function inside of the super function, which is the one that we have inherited. So super tick delta time. And over here, we're going to do the same thing. So this one is for our player input component. So we're going to say super : : and we're going to say set up player input component. There we go. Passing our player input component over here. So now this is where we are going to bind inside of this function. This is the function that's called to bind these with these over here, because we need to connect these with our code, which is this over here, in order to make it work. So what we're going to do is I'm going to take my player input component, which is the parameter. So player input component, and I'm going to say dash and greater than sign, and we're going to say bind axes like this. So bind axes, and I'm going to bind the move forward axis, and I'm going to bind that inside of this, which is this class, and I'm going to bind it to this function over here, which is a player character, and we need to say and sign and paste that over here, and voila, there you go. Now you will see this. So you see this over here, player input component, it shows this red line. It will not throw an error, I believe. So let's Control Shift B just to make sure, but we need to import something if you want to remove this error. But I believe it will not throw it. We're going to check it in a moment. So come on, yada, 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 yada. Yeah, it's not going to throw an error. As you can see, build has succeeded, but it's not going to give us autocomplete for this. So if you want autocomplete, you need to go here and you need to type include like this. So include, if I can spell it correctly, in quotes, and it's going to be components like this and slash, and it's going to be the input component. So when you type it out over here, now it will give us autocomplete when we try to add something to it again. So if I go over here and I say input component dash greater than sign, so it's greater than, you see, it's giving me autocomplete to select from the available functions. So I'm going to use again bind axes, and basically I'm simply going to copy this time, so because it's going to be the same thing, but except for the move forward, it is going to be move right, and we're going to bind it inside of this, and over here it's also going to be move right. Now, what the hell is this? What am I doing? This right here, the name inside of the string that I'm giving, it's actually the name over here that we named our access to map or access mappings. This move right needs to be exactly named like that, move right. If, for example, here I have move right with capital R, and over here I type it with lowercase r, it is not going to work. Same thing for the move forward. So you need to make sure that the capitalization is okay, and you get the point. So we are going to bind this access mapping that we have defined over here, and we are going to bind it inside of this class with this function, which is the move forward function, which means when we press, for example, A or D key, the move right is going to be called, it's going to call this function move right, and it's going to execute all the code that we put inside. So before we do that, I'm simply going to bind the rest of this. So I'm going to go back over here and copy this and paste it 2 times, because this over here is going to be our mouse X, and we are going to bind it over here with the mouse X, and over here bind axes, and here it's going to be mouse underscore Y, and we are going to bind it with the mouse Y. And the last thing left for us to do is to bind the attack. So here we're going to say attack, but that will come later on. Don't worry about that. When we add the attack, we'll come back to it. So now let's move forward. Here, in order to move forward, first of all, I'm going to test if we are not alive. So B is alive. And notice I'm using an exclamation mark, which means it will make what's after it the opposite, which means essentially over here we're asking if we're not alive. And over here we set is alive to be true by default. Later on, when we add to our game damage system and we detect damage, we're going to set is alive to be equal to false, and the exclamation mark will make it the opposite, which is true, and we will hit the return statement. And when we hit a return statement in a void function, it will simply exit outside of that function, and it will not execute the code that is below it. So that's how it works. But if we are alive, then we are going to test if we are not attacking. So if B is attacking, so again with the exclamation mark, which means we are making it the opposite. So exclamation mark makes the boolean after it the opposite. So if this is false, it will make it true. If it's true, it will make it false. So if we are not attacking, then we are going to move our character. And for that, we're going to get the rotator. So F rotator, and I'm going to call it camera rotation, which is going to equal to get control rotation. So get the control rotation. This is basically the rotation of our character controller. And we're going to say cam rotation dot pitch. We're going to set that to be equal to 0.0 f, which is the pitch rotation of the camera. And we're going to say here f vector move direction is going to be equal to cam rotation, and we're going to say here dot vector, which is basically, you see, convert a rotation into a unit vector facing its direction. Basically, it's going to convert this rotation, this right here, rotation that we got, it's going to convert it in a vector that's facing the direction. There we go. And we set the pitch to be equal to 0. If you go over here and in the player Dwolf, and if I select the mesh, and if you hover over, the pitch value is actually the Y value. So we set the Y value to be equal to 0 so that we can rotate our character towards his direction, because the Z axis in this case, you see the Z rotation is the one that is responsible for facing the direction inside of Unreal. So there you go. The next step is to get the character movement that is by default over here. You see, here is our character movement. And for the character movement, we are simply going to add to the, so we're going to say add input vector, so add input vector, and we're going to say move direction multiplied with the value over here that we are passing. Now this value, you see this value over here is basically going to be this value. It's gonna either be +1 or -1, as I said, depending on the movement. So depending on the movement, if we are pressing the W, it's gonna be 1. If we press the S, it's gonna be -1. So that is going to determine if we're gonna move forward or backwards. And by the way, you see this red line over here? We need to import this if you don't want to see that red line. So we need to go over here and say include, and here we need to say colon, or actually quotes, and it's gonna be game framework, and it's gonna be backslash, and it's gonna be character movement. There you go. Character movement component. Now, by the way, if you are wondering how do I know where are these inputs, well, you simply need to copy, you see the character movement component, for example, and let me open a new window over here, and character movement, there you go. You need to go into docs for Unreal Engine, and basically you need to go, let me just search for the documentation over here and paste it, and you need to go under C++ API. So Unreal Engine docs, you get the point. You can simply Google this. It's not complicated. And you need to go U character movement component and scroll way down at the bottom. And this is where you can see this. So you can omit classes and take what's after it. So you can take what's after, which is the game framework. As you can see, game framework component, movement component .h, and simply paste it over here. And there you go. And for our movement to the right side, I'm going to do the same thing. I'm simply going to copy all of this. Let's copy it, paste it over here. So let's go and paste it. B is attacking. We have the camera rotation. Pitch is set to 0. But over here, we're not going to use the camera rotation vector. Instead, we're going to say camera rotation. So cam rot dot, and we're going to say rotate vector, you see, which is going to rotate this vector. And we're going to say over here f vector colon right vector. Basically what this function is going to do, it's going to take this vector over here, camera rotation that we got, and it's going to rotate it. So if I hover over, it's going to rotate the vector rotated by this rotator. It's simply going to rotate it towards the right. You see, f vector right, it will rotate it to the right side. And then again, get the character movement, add input vector, move direction, and multiplied with the value, and there you go. Now we can test this out, but before we do that, let's also finish the mouse and mouse X and mouse Y. So here in the mouse Y, what we are going to do is I'm going to say float input that I'm going to get, it's going to be equal to the value over here, and this value is basically going to be this value. You see the scale over here, it's going to be this value. And by the way, over here, if you want the inverse, you can either use -1 or 1 for the y-axis. So you can either use -1 or 1. But over here, what I'm going to do is float input. It's going to be equal to the value. We're going to get the value. And I'm going to multiply that by 100f. And how do I know 100? Well, I have experimented. You can try with 50, so on and so forth. You get the point. And over here, I'm going to multiply that with the get world, and I'm going to get the world, and I'm going to get the, so get delta seconds from the world. And the world is, well, basically, well, the world is, well, the world component. And again, you see over here, it is showing an error. Again, we need to import this if you don't want to show it. So you need to go here, include engine / world.h in order, well, to remove that red line below it. And simply because this is for our X, we are going to rotate the pitch, or actually the yaw, excuse me. So we are going to say add controller yaw movement or yaw input, and we're going to pass here the input, which is the one that we got calculating all of this here. And we're going to do the same thing over here. So copy this and paste it over here. So we have the mouse Y. And again, we are going to input value multiplied with 100, get the world and get the delta seconds of the world. But over here, we are, instead of adding the yaw, we are going to add the pitch. So here I'm going to say pitch input, and voila, there you go. So Control-Shift-B to make sure that I didn't do an oopsie anywhere. So make sure that I didn't do an oopsie. And now we will be able to test it out. If, of course, I didn't do an oopsie. So over here, yeah, build has succeeded. Everything is cool. So if I go over here now in the engine, and if I hit the play button, we should be able to, as you can see, we are able to look left and right, and I'm able to move the character, as you can see. So I'm moving the character. We cannot move up and down. So what is this? Teacher, you said you're gonna move up and down, but calm down. There are still some things that we need to do. We need to go here in the blueprint, and for the player dwarf, select him. And over here, as you can see, on the right side in the details, where it says pawn, make sure that all of this here is unchecked. So don't use controller rotation. You get the point. Uncheck all of these. Compile and save that. Also over here for the spring arm component, we need to go over here. You see in the camera settings for the spring arm component, and we need to say use control or use pawn control rotation. Make sure that is checked. So make sure that is checked, and also go here, compile and save. Any change that you make sure that you compile and save that. So if I go back now and hit the play button, you see now I am able to move up and down, and I'm able to move left and right, and I can move the character. But you see he is moving like, you know, like a weird guy. He's not rotating in the direction where he is moving, as you can see. Now we can fix that as well. We simply need to go here in the player dwarf, click on the character movement component, which is this over here. So click on it, go in the details and scroll where it says over here. Let me just find it. Here it is. Character movement rotation settings. So rotation settings. First of all, I'm going to set the rotation on the Z to rotate by 1080 units. This is basically the speed of his rotation, how fast he will rotate. And also over here, I'm going to check the checkbox for orient rotation to movement. This basically is going to, if I hover over, see, if true, rotate the character toward the direction of acceleration. Basically, this means it will rotate the character towards the movement direction where he is moving. Make sure that you compile and save that. And if I go back in the arena, hit the play button. So now you see he is rotating towards the, well, rotation where he is moving. Now don't worry about this because we are not animating him. So currently I am holding the down. You see I'm pressing forward and you see how he is rotating. Don't worry about that. We will fix it when we start animating the character, and that's gonna start in the next video. And until then, Fire here from Livestream.com. Take care and stay out of jail, I guess. See you then. Moving forward with our game, let us create the animations for our player dwarf, and for that, here inside of the blueprints folder, right click, and we are going to go under animation, and we are going to create an animation blueprint. Of course, here we need to select the skeleton that we want to animate, which is going to be the same skeleton that our player dwarf is using. So not the shield, not the warhammer, but this one, dwarf, ground R, blah, blah, blah. Click on OK, and there you go. Now I'm going to call this bad boy character anim underscore BP, short for blueprint. And of course, I'm going to double click it and open this dude inside of this editor. Now, this is the final animation pose that is going to be our animation. But before we start adding the animations and yada, 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 we do need to go over here inside of the variables and create all the variables that we need. So first of all, we are going to have the speed variable. So here, click on the variables plus and add a new variable speed, which is going to be type of float. Next one we are going to have is in air. And over here for the in air, I'm going to set it to be a Boolean. Next one is going to be call attack, which is also a Boolean. So I'm going to leave it as a Boolean. We are also going to have delay between attacks. So here I'm going to say delay between attacks. This one is going to be a float. So select it from here, from the drop-down list, and select a float. I'm going to compile and save that because I want to select delay between attacks. And over here in the details panel, I want to set the default value for delay between attacks to 0.1, which means we can attack every 0.1 of a second. Now, next we are also going to have a direction, so click on the plus and it's going to be direction. It's also going to be a float and we're going to calculate the angle of the direction where we are going. We will see that in a moment. Another variable, and this one is going to be isDead, which is basically going to represent, so over here I'm going to select it a Boolean. It is going to represent if the player is dead or not. So when he dies, when isDead is true, we are going to simply play the death animation. and click for another variable, which is going to be our character. So character over here. Now the type of the character is going to be, we're going to go here in the details and click on the drop down list here where it says the variable type, and here we are going to filter for the arena character. There you go. But hover over it. So hover over it and select from these four. So you have the object reference, the class reference, and all of the good stuff. Select the object reference. This is what we want. Compile and save. Now, before we continue again with the animations, we do need to initialize something such as the character. And I'm going to do that inside of a function. So over here we have functions. You see over here we have functions. So I'm going to click on the plus button and create a function that I'm going to call init character. Now inside of the init character function, we are simply going to cast to arena character. So from here, drag a node and cast to arena character. Now we don't want cast to arena character class, but here to arena character. And who do we want to cast? Right click and type here, try get pawn owner, which is going to get the owner of the pawn who has, or which is going to get the pawn owner of this animation instance, which is going to be the player because he's going to hold this animation. So drag the return value over here and plug it into the object, and there you go. And from here, I can take the character that I've just created here in the variables and I can set the character. So let's go and continue the execution order from here to here and plug in as arena character over here to save him as a reference. So this is for our init character. Now we are going to have another function, which is actually going to be a macro. And over here, I'm going to create a macro because a lot of you guys have been wondering what this macro is. Basically, it's the same thing as a function. And if you want to learn more, this is your assignment. Look it up online. Type what is the difference between functions and macros in Blueprints, because I want you to get used to searching online and finding the things that you are interested in, especially if it comes to solving a problem. So make sure that you type the difference between functions and macros and you will see what this is, but basically it's the same thing. So let's click on a macro and I'm going to call this macro get direction. So get direction and speed. Why do we need a direction and a speed? Well, because inside of our animations, we have the blend space called Gladiator Anim Blend Space. And if I go over here in the content and if I search for it and if I type Gladiator Anim Space, here it is. What this is that we blended two animations. We blended the idle animation and we blended the run animation. So depending on the angle, you see how he's gonna run fast and yada yada yada, you get the point. So depending on the direction and the speed, our character is going to behave like that. And if you're not sure what a blend space is, make sure that you watch my other Unreal Engine courses, such as the one where I create a game where the time moves when you don't move, and also the one with the zombies and all the other ones that I have, because I cover that there. So I'm not gonna go into every single detail in every single course because I have every course covering all those things. So basically, but just in short to tell you, the blend space will blend two animations together based on these conditions over here. So we have the horizontal axis and the vertical axis. So we are going to calculate those over here inside of the get direction and speed. Now, when it comes to the input over here, so you see we have the input. Now the input, click on it. So click on this over here. So click on this input. Let me just take my highlight tool. So click on this, and then over here we have inputs and we have outputs. So click on the inputs plus here for the new parameter, which will allow us to attach a new parameter. I'm going to call this one target. And from here, I'm going to call inside of the search for character. So we want the character and we want the character object reference. So this is the input. And we also want the output, and the output is going to be two parameters, basically two floats. One is going to be the speed. So you see here, one is going to be the speed, and another one is going to be the direction. And both of these are going to be floats. So make sure that you select them and make sure that they are floats because they are outputs. Now from here, as we see, which is obvious, we need to calculate those. So what I'm going to do is from the target, I'm going to get the velocity. So from here, I'm going to say get velocity, which is simply going to get us the velocity from our target. And what I can do is to calculate the speed, which is very, very simple to do. From the velocity, we simply need to get the vector length. So over here, we're going to say vector length. So it's length, here it is. And this is going to be the speed. So simply plug this bad boy inside of the speed. That's all there is to it. Now it's pretty easy, as you can see. And what is the vector length? Basically, if we're moving, the vector velocity will have a value 0, or it will have a value greater than 0 for x, y, and z. But vector length will put all those values in a single value. So for example, if we're just moving on the x-axis, the y and the z-axis will not have any values in the get velocity. They will have 0. But when we take the vector length, it will have all those combined velocities into one, and we are going to output it as a float. And again, if you're not moving, it will be 0. If you're moving, the value will be greater than 0, depending on the speed, and compile and save that, by the way, depending on the speed of our, and if I go back over here, and let me just find in my blueprints, my player dwarf. So depending on the speed that we have for our player dwarf over here in the character movement. Now, when it comes to the direction, now that one is a little bit tricky. So from our target, we do need to drag over here, and we need to get the mesh. So we're going to get the mesh. Let me just find it over here. Get mesh. Where is it? So I think I do need to type from here, get mesh. Here it is. Thank you. So get mesh put together will get you the mesh function that's going to get the mesh for us. Now from the mesh, we are going to get the world rotation. So from here, I'm going to say get world rotation. And what we need to do from the, or with the world rotation, because you see a world rotation is a vector, so x, y, and z, we are going to unrotate the velocity vector. So from here, I'm going to say unrotate. And we don't want the first one, not the quad, but this one, unrotate vector. As you can see, returns result of vector A rotated by the inverse of vector B. So I'm going to plug this in over here. Now, to be honest, this method that I'm going to use right now to get the direction, to calculate the direction, especially now that we're going to create a function that's going to be called get angle between, I'm not 100% sure how that works behind the scenes. Now, let me show you. First of all, here in the functions, I'm going to click on plus. And we are going to create a function that is called get angle between. So get angle between, as you can see over here. Now for our get angle between, it is going to have two inputs. It's going to have two vectors. So in the inputs, click plus 2 times. And one is going to be A, another is going to be B. So let's go over here, A, and another is going to be B. And their types is going to be a vector. So click on the drop-down list and make sure they are vectors. So what we're going to do is we are going to get the angle between vector A and B. So first thing, from here, I'm going to drag to A and I'm going to normalize it. So normalize the vector, there you go. Copy and paste this normalize, and I'm going to normalize this other vector as well. So gets a normalized vector, you see, gets or normalize will basically get a normalized unit copy of the vector, ensuring it is safe to do so based on the length. And over here, it will return 0 if vector length is too small to safely normalize. So what are we going to do with this is that we are going to get the dot product. So we're going to say dot product, as you can see, from both of these. Now, this is what I'm talking about. So if I go over here and tell you the dot product returns the dot product of two 3D vectors, and it gives us a reference. See over here, Math World. So let's go to Math World. This is the explanation. Now, what I want to tell you is sometimes, to be honest, like I over here, I don't know how this works behind the scenes. I Googled it online, how to find the angle between these, how to get the direction in order to calculate the animations and all of the good stuff. So as I said, sometimes you can find something that works and you don't have to know how it works, because you see the dot product, what is this? And if you go over here, you see you need to read through all this. And then if there is somebody watching this, please make sure that you explain below this video for other people to understand. I didn't go in that depth because, you know, as I said, sometimes I don't even want to understand how things are done behind the scenes. I just know what it does. But again, if somebody can do it for us, please leave an explanation below the video. Now, the next step to do is from here, we do need to take the break vector. So we need to break our vector. And I'm also going to break the vector over here. So break both of these vectors. And what we are going to do next is from the dot product that we just got, we are going to get an A cos D, which is a cosine in degrees, but the inverse of the cosine. And again, for this one as well, I took over here, you see, returns the inverse of the cosine. Now, you can look this up in more details. Again, I don't know what or how it is working behind the scenes. Now, over here, we are going to plug this into the result local variable. What is a local variable? Well, over here at the bottom, you see local variable, we are going to create, so click on the plus, and we're going to call it result, which is going to be type of float, and it's only local to this function. It cannot be accessed inside of this function or inside of this function over here, so it cannot be accessed over there. Only local to the function where have we created it. So I'm going to take the result, and let me just take the result again and set it. So we're going to plug this into the result, and we're going to call the result from here, angle between. So plug in the result. And what's going to happen is that we are going to have a return node. And let me just find where it is. Where is my return node? So over here, right click. So we have angle between, and we have an output. So there it is. Here is our output. And for the output, I'm going to simply return an angle. So I'm going to call it angle, and from here vector, or so click on where it says vector and change the type to a float, because again, we are returning an angle, and this angle is going to be the result. So let me just take from here the result, get it, and plug it in over here. Now, again, what you need to do is select this angle between, and for the output, click on the plus so that you can have an output over here to plug this in as I just did. So what I'm going to do is I'm going to compare from the from the vector that I broke from the normalize. I'm going to compare this X vector. I'm going to say if it's less than the float, and which float? Well, the X from the other broken normalized vector. And that result we are going to plug into a branch over here, and that condition is going to go from the set over here. So when we set the result, go inside of that condition, and let's move this over here. So if that is true, we are simply going to multiply. So if it's true, we are going to negate the float. So from here, we're going to take this float, and I'm going to type negate float, which is going to multiply it and set it by 1. If I hover over multiply the specified value by -1 and set it, so plug it in over here and then plug it in over here for the execution. And going from here false, just plug it in, and there you go. In either case, it is going to return the result over here that we set up over here. As I said, sometimes you will not understand, or you will find something that needs a little bit of explanation in order to understand what is going on. So, as I said, I don't know how dot works behind the scene, ACOS, but I know that this will get us the angle between two vectors. So it will get us the angle between two vectors that we're going to use in return. So compile and save, and we're going to use it over here when we unrotate the vector. You see, when we unrotate, we are going to call from here get angle between. So call it get angle between. Now you see over here we have another problem. We need to plug something in over here, but we don't have anything to plug it in. Well, no biggie. Let's just go back over here and angle between and select it. So click on this over here, select it. And over here in the details where it says pure, check the checkbox for the pure. It's gonna make this a simple function that doesn't require calling in terms of plugging in the, I don't know how that's called, the input, this over here. So it doesn't require this over here as we did. You see my point. It's simply a function that can execute, or it will do what we ask it to do by simply calling it like this. So plug in vector A, and we also need the vector E, or actually vector B. So make vector from here. There you go. And I'm simply going to set the Y to 1 and return the angle over here. And this is how we are going to calculate that direction. So compile and save. So these are all the calculations we need to perform before we can actually start animating the character. But as I said again, and not repeating, the dot product and the cosine, I know that it will get the angle between two vectors, but I don't know how does that work behind the scenes, because I googled it, and you will do the same as well often in your programming. Now let's go back here in the event graph and initialize everything. So I'm going to right click over here and I'm going to search for Initialize Animation. There you go. And from here, I'm going to call the init character. So init character. So when we initialize the animation, we are first going to init the character, which is going to set a reference to the character holding this animation. Now, try get pawn we're going to delete, but from here, from the blueprint update, we are going to go inside of a branch. So drag and create a branch. And what is the condition for the branch? Well, the condition is going to be, I'm going to get the character. And from the character that we got a reference in the init character, I am going to drag here and I'm going to test if is valid. We don't want this one with the exclamation mark, or actually with the question mark. We want the one above it. So is valid. So we want this one. And we want to plug this inside of here. Basically, this will test if the character is not equal to a null pointer. So we have a character and we can work with the character. So now we can plug in all the values that we have here. So we can plug call attack, we can plug in is dead. So if it's true, if we have a character, so if it's not equal to a null pointer, so if it's true, from here, I'm going to call set call attack. And our call attack is basically this right here, our variable. And we are going to set it from the character. So I'm going to get the is attacking. So get is attacking. And how can I get it? Well, if you remember, in the previous video over here, inside of the arena character, we created is attacking and is alive. And we made it blueprint read and write. Even if we only made it blueprint read, we would be able to get it now over here. So it's only possible because of that. If we did not set this blueprint read write or only blueprint read, then we will not be able to do this. So we're basically getting now this variable, and in a moment we will get this one as well from our code inside of the blueprint. So get the is attacking and plug it in over here, and later on when we start to attack, we will put is attacking, we will make it true and false and so on and so forth. So don't worry about that. Now, next, we are going to set the speed. So let's go from call attack. We're going to say set speed. So set the speed. And the speed is going to be, well, from the direction that we are going to get. So over here, I'm going to right click and I'm going to say get direction and speed. Here it is, get direction and speed. So I'm going to set the speed over here. And the target is going to be our character. So plug in the target character. As you can see, so we have now the speed. The next that we need is to set the direction, which is basically the angle of the direction. So let's drag another node and say direction. And here it is, set the direction and plug it in over here. And the last step is to set if we are alive or is dead. So drag a node from here and we're going to say is dead, set is dead. And we're going to get that reference from the character over here. And we're going to say is alive. So get is alive. And from here, we're going to test if not bool. So if it's not alive, we're going to plug it inside of over here, compile and save. So this is what we need in order to make everything work. And what do I mean to make everything work? Well, our animations now, we can now go inside of the anim graph. And again, over here, if you went through my other courses, if you didn't, please go, because over there I go into more details about blueprints, what is a branch, because I talked about it in my other courses. So you can go inside of the zombie horde course, you can go inside of the infinite runner, you can also go inside of the course where I create the time-stopping first-person shooter, because over there I explain these things in more detail. I'm going to cover in every single course, so go over there and watch them. But if you understand, basically from here we're simply setting the call attack, getting that from the player, setting the speed from the direction and speed, setting the direction, again, same thing, setting is dead from, you get the point. because we're going to use these variables now inside of our anim graph. So first of all, I'm going to create a state machine. So create state, or simply let me file it over here, state machine, or add a new state machine. Click on it, and instead of new state machine, I'm going to call it dwarf state machine, and plug in the result over here, which is basically going to do all the animations that we have inside of the state machine, and then it is going to plug in those animations into the final animation pose. So double click on the dwarf state machine, it will take us over here. Now right click and add a state, which is basically our animation. First one is going to be move, select it, and so click on it and Control W or Command W. Is it Control W? Yeah, Control W, here it is. Now this one is going to be the attack, and select it. So select the attack, Control W. So why isn't it allowing me to select it? Finally, Control W to duplicate it, and I believe on Mac it's Command and D. And this one is going to be our death. So these are going to be our animations. The first one, of course, is going to be the move animation, and this entry point, you see this entry is going to be, well, in which animation we're going to go first. So we are going to go into the move animation. From the move animation, we're going to go in the attack, and vice versa. From attack, we're going to go back to the move, and we can go from both of these to death animation when we die. Now it's time for us to add these animations. So double click here, the move, and you see over here we have the result, which is basically, well, the animation output pose. And we want over here the blend space for our gladiator. And here is where we have the direction and the speed that we set over here. We're setting the speed, we're setting the direction, we're calculating that in the get direction and speed. So that will be plugged in to the, let me just find it over here. What was the name of it? It's gladiator anim space. So let me just find it. Gladiator anim space. That is going to be plugged into these values, the direction and the speed, which is going to control this animation. And again, if you went and watched one of these courses that I told you, you'll understand how that goes. Basically, it will blend the walk and the idle animation based on the values, and it will rotate the character, as you can see. So this is the preview. So let me get the direction. So over here, direction, get, and speed also. So from here, get the speed as well, and plug them in. So this is the direction, this is the speed, and voila. So compile and save. Now we do have these errors over here. That is because, well, we didn't plug in over here the rest. So let's do that. So for the attack animation, you see we need to plug in a result. So I'm going to plug in the attack one. So take the attack one from here. So from the animations over here that you see in the asset browser, and simply plug in the result over here. There you go. And let's go back, and inside of our death, so in the death, we are going to play the death 2. So let me just find it over here, death 2. There it is. Drag it and plug in the result, and there you go. So we have all the animations, but we do not have the conditions for those animations. You see over here these lines that are pointing. So we are going here from move to attack, and from attack back to move, but we need to have some kind of conditions for that to happen. So when you click on this over here, this is where you can set up the conditions. So double click on it, and we can enter. So we can go, you see this is the condition when we go from move to attack. And what is going to be the condition? So let's go here, and we're going to get the call attack and plug it in. And if you remember over here, you see call attack, we are setting that from is attacking from the character, which is this inside of our code that we will set when we attack later on in the code. So when we attack, we will use that variable, and we will set that variable to true or false value, which is going to trigger the attack animation over here based on that condition, which is really cool. So let's now go back from attack to move. So double click this over here, and what I'm going to do is right click and search for get relevant anim time, and we want the fraction. So get relevant anim time remaining fraction. This is what we want. Basically, it will give us the time remaining from this animation. So how much this animation has left until it's finished playing. And what I'm going to do from here, I'm going to plug in the less than or equal to sign. I'm going to test it with a float, and that float is going to be the delay between attacks. So I'm going to test the value, and the default value of this one is 0.1 and plug that in over here. So if the remaining time of the animation that's currently being played, which is basically the attack animation, if that time is less than or equal to delay between attacks, if that is true, we will be able to transition from attack to the move animation and, well, get back to it. Basically, that's all there is to it. And finally, for both of these to go to the death animation, let's click on this. We're simply going to get is dead. So get is dead and plug it in over here and do the same thing for over here. And let me just go is dead and get it and plug it in over here. And I got carried away. Got carried away. I have issues talking. So remove this in air. We do not need it. So we do not need it. I was testing something, so we do not need it. Anyways, over here we have the is dead, and that will be over here. You see, if it's not alive, so we're testing, you see, is alive. If it's not alive, we're going to plug it into the death over here, which is basically this over here. And we will do that in our code when we drop the health to 0. That will come, don't worry about that. And now I can compile and save, and voila. So now we see that the animation is working based on everything that we set up over here, that we calculated over here. You get the point. And a good assignment for some of you guys, I mean for all of you guys, but for those of you who have the extra time to search, to explain to us the dot and the ACOS, that will be really, really nice. And again, I'm showing over here that it doesn't matter that I'm teaching you these concepts. I don't know everything, and you will never find a person that knows everything about Unreal, Unity, or any other engine, or all calculations and whatnot. So it can happen that you know that and I don't. And that's normal, we're human beings. So help us out, let us work as a community. And we explained all this over here, we explained all this over here and how we are doing. So now what we can do is we can go in the player dwarf and select the mesh character, and over here in the animations, we can click on the drop down list for the anim class and we can select the character anim BP, and automatically you see that the animation is being applied on our character. So compile and save that and we can test it out. Now, one thing that I want to point out is in the previous video, when we created the movement of our player, our character over here was not rotating correctly. So you see now I'm going forward, he's rotating forward. I'm going to the right side, he rotated to the right side. Now, going backwards, I'm pressing S, he's rotating to the direction where he is moving, and you can see he is also being animated. As I said in the previous video, he was not rotating. Now, if you have the same issue, if he's not rotating the same way as you see that he's rotating now, and you wrote this same code as I did over here, so this code over here for movement, for the move right, and this one for the move forward, and you plugged in the correct bindings, so you didn't by accident set the move forward, bind it with the move right, you get the point. You did all that and it's still not working. What you should try, and let me just save all of this. What you need to try is, first of all, check over here if for the player dwarf, so for the player dwarf over here, that you unchecked all 4 of these under pawn. All 4 of these need to be unchecked. So make sure, and if that is the case, check over here for the character movement, and over here where it says velocity or character movement rotation settings, you set the rotation rate at 1080 for the Z, and you set orient rotation to movement, and that is also checked. So if that is also true, also here for your spring arm, you made sure that the camera settings and everything over here is checked. So if all of that is okay and it's the same as what I just showed you, and it's still, the character is still not rotating, what you should do is close Unreal Engine and open it again and see if it works. If it does not work even after that, what you should do is go in the blueprints, select the player dwarf and delete it. So press delete and click here, force delete and delete it, so on and so forth, and create a new blueprint. Again, right click, go over here in the blueprint and search in the classes for the character or player character, the one that we have created that inherits from the arena character. Create a blueprint out of that, go inside of it. So go inside, attach the meshes, attach the animations, attach the spring arm and the camera, and make sure that you set all the settings the same. So for the pawn over here, set the same settings. Also here for the spring arm, set these settings in the camera. And for the character movement, set the same settings I showed you a moment ago. and then it will work. Because sometimes, for some reason, unknown to me, I have no idea, it happened to me, this is how I fixed it, so I'm giving you the solution so that you don't get frustrated. So click on play again, and you see the character is moving and he is being rotated. You see, look at the little dude, look at he's so fat and funny, look at this. And you see, he's going in the direction and facing the direction, and also being animated along the way. And we explain all that. If something is not clear, please ask. Link will be, or actually the comment section is below the video. Ask if something is not clear. This video is already long, but we had to explain everything what was going on. So far here from AwesomeDudes.com. I will see you guys in the next video. Moving forward with our game now, we have our character, we have animated the character. Let us now create the weapons before we attach those weapons to the character. So let's go here in our C++ classes here in our Gladiator arena. I'm going to right click over here and create a new C++ class. Now this one is going to inherit from the actor. So click on the actor, and an actor is an object that can be placed or spawned in the world, as you can see. So we're going to click on next over here, and I'm going to call this bad boy pickable item base, because we are going to have a base class and we're going to inherit from it. So I'm going to click here, create, and of course, because we are mere mortals, we need to wait for C++ to compile all the code, to create everything. I don't know why it takes so long, and yeah, I'm thinking about singing to you while we wait, so na 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 na. I'm just kidding, man. But yeah, I mean, this is awkward. This is really awkward while we wait this. So come on, compiling, finally, hopefully, thank you. Okay, so now we can move forward. So here it is inside of our pickable item base, or base item, however you want to call it. So there we go. Inside of here, we are going to have a function that we are going to use to attach these items on our components. So right here inside of the public, below our tick, I am going to create over here a bool, because this function is going to return a boolean, and I'm going to call it attach item to, and here the parameters for this function, so you can close it like this with a semicolon. The parameters are going to be skeletal mesh component, which is a pointer, and it's going to be our mesh root. And it's also going to have an F name for the socket, and the socket is basically the name of the part of the body for our warrior, for our gladiator, where we want to attach. For example, the hand, or so on and so forth. We will see that when the time comes, don't worry about it. And we're also going to have here a boolean is used to know if the weapon is used or not, because our enemy is also going to have these weapons, and our character is also going to have the weapons. But for the character, we are going to leave the weapons, as you saw in the preview, on the ground, and he needs to come to them to get them. So we will see as well why we're using this is used, because if we don't use it like this, then our player will be able to steal the weapons from the enemy, which is really fun. But yeah, we leave the enemy with no weapons. Now, going back over here inside of our scripts, I'm going to right click and create another C++ class, but this class is going to inherit from the pickable item base. So we do need to click over here, show all classes, and we need to filter for pickable item base, which is this over here. So click on it, go on next, and over here I'm going to call this one, this is going to be our pickable weapon. So we are going to say here pickable weapon, and simply click on create class, and it is going to create a class. Now again, we are back at the awkward situation. You can rewind while you're waiting for this to compile, because I'm not gonna cut off the video. It takes a lot of time to edit all this, to put together, and yeah, you get the point. So let me take the pickable weapon H, and over here we have the generated body. And below the generated body, I'm simply going to create here our public, because these are going to be our public variables. We are going to have a constructor, which is a pickable weapon. So pickable weapon, this is the constructor for our class. As you can see over here, we are inheriting from the pickable item base. So yeah, there you go. Now we are also going to have components over here. So I am going to go below our pickable weapon, which is our constructor. Let me also implement our virtual void. So virtual void, this is going to be our begin play, which is going to be override, and we're also going to have virtual void. Or actually, I'm not going to implement the tick, because we do not need the tick. Now we are going to have a uBox component, so component like this, and it is going to be a pointer, but this is going to be a function that returns a box component, and I'm going to say get damage box like this. And we can set here to be a constant because, well, the box component can be a constant. Now, pay attention over here. We have here, you see like an error that it says identifier uBox component is unidentified or unidentified. What you can do is you can go over here and you can import or include that component, but we can also do something like this. This is called forecasting, I believe. Was it forecasting or for declaration? I forgot the name, but basically here we can say something like class uBox component and it will go away. You see this right here will go away, the error. Now, what is the wisdom behind this? Well, the wisdom is if we take this box component and if let me just open my Google Chrome, uBox component. Let's try it over here just to show you what I mean. So if I go over here in the documentation and I search for it and I go here in the C++ API and we want to import the bad boy. So we will do something like this, components, box component H, and we will come back over here and we need to do it above the generated dot or generated.h file. So it will be include like this and we will put it in quotes. Now, what is the issue over here is if we need to use our pickable weapon inside of another class, for example, let's say we want to use our pickable weapon over here in the arena, we would need to import that. So let's say here in arena CPP, we would need to do something like this. We would need to say include pickable weapon. You see, we will need to say it like this. Now, the issue over here is that with the pickable weapon.h, we will also import all of its components, such as box component.h, so on and so forth. But it can be the case that we don't need box component in the arena character over here. So we don't need it. So why should we import it? It's just gonna, stack up the compile time and so on and so forth. And because of that, we can use this. Instead of using components, including and so on and so forth, because now that we have included this component, we can omit this, so we can remove this. And again, you see over here, we don't have any issues. But as I said, if we just include this and we can remove this over here, it's basically going to declare this class here, which means we can use it. It will not throw any errors. But if we import, for example, our pickable weapon.h over here in the arena character, now it will not have the include for the box component. So this right here, the class box component, is only relevant to this class and it will not import it over here, which means our compile time will not stack up. So that is good to know. And I forgot the name of this. Was it for declaration or forward declaration or something like that? I forgot the name, so sorry. I tend to not memorize the names, but I've explained what it is. So here we have our box component, as we said. Now I'm also going to create here protected, which means that basically these variables now that we declare inside of this protected will only be available inside of this class. So we will be able to use it in the class or in the class that has inherited this class. It will not be available outside of this class, so we will not be able to access them over here. So what I want to declare over here is going to be a u property, and it's u property like this, and it is going to be edit anywhere, which means we will be able to edit inside of our blueprint, and this is going to be u sphere component, so component like this, and it is going to be a pointer, so asterisk sign, and I'm going to call it my sphere like this. And I'm going to simply take this over here and paste it. So what I'm also going to do below, we are going to have a u skeletal mesh component like this. It is a pointer. I'm going to call it my skeletal mesh. There you go. Another one is going to be our uBox components. Over here, I'm going to say uBox component, and I'm going to call this one damage box. So damage box like this. There you go. Now, as you can see for our sphere, it is also generating this error, so to say. Now, what we can do is we can again use this class to declare it, or we can put it over here, but I told you the consequences if we put it over here. But we can go here inside of the pickable weapon, and over here we can include, and I can say in quotes, and I can filter here for components. So it's components, not com or whatever. So components, and I can say slash like this, and we can import our sphere component.h, and there you go. So even if we import the sphere.h over here, it is going to it is going to stop, not start, complaining over here in the .h file. But the difference is if we import the .h file, for example, again, if we use an import pickable weapon .h over here, it is not going to include this over here. So it's not going to include it because we are importing .h file, which means it will not include what we have over here. So moving forward, we need another include before we continue. It's also going to be from components. Why is it giving me this? This C++ and Unreal Engine are killing me. So we're also going to have a skeletal mesh component, and voila, there you go. So I'm going to declare our constructor over here. So it is going to be a pickable weapon base, not item. So a pickable weapon, colon, and over here we're going to have a pickable weapon like this, and this is going to be our constructor. Why do we need a constructor? Well, I want to declare everything inside of the constructor. You can also go over here and take this begin place. I'm going to right click, quick actions and refactoring, and create a definition of begin place. So you can also place your declaration inside of the begin play. And I'm also going to take this damage box, right click over here, and I'm going to, well, just declare it over here so that it does not complain. Okay, now inside over here, inside of our pickable item weapon, which is the constructor, I am going to create the root component. So root component is going to be equal to create default sub object, and it's going to be a type of scene component, and it is going to have a name root. So let's going to go over here, and we're simply going to say root, not rit. It's going to be root component. The root component, simply the top component inside of the blueprint over here. So for example, if I go inside my character, this is the root component. You see this over here? The capsule component here is the root component. So it's gonna hold all other components that we attach to it. Nothing complicated. Now I am going to create the sphere. So my sphere is going to be equal to create default sub object of the sphere component, which is going to have a name and all caps text like this. And inside we need to do it in quotes, and I'm going to call this one sphere. Now we do need to attach the sphere. So I'm going to say my sphere and dash and greater than sign, and we're going to say attach to component, and we're going to attach it to the root component, and we're going to use F attachment rules or F attachment transform rules, colon, keep relative transform. So we're going to keep the relative transform. As you can see over here, the relative transform is going to keep the transform relative to the parent. Basically, that's all there is to it. Now we are also going to go over here. My skeletal mesh is going to be equal to create default sub object of skeletal mesh component. So it's skeletal mesh component like this. And inside we are going to create a text like this, which is going to be the name. So let's do it like this. And the name is skeletal mesh hammer. There you go. And again, we're going to use this same thing. So we can do something like, I'm simply going to copy this. So let's copy all of this over here. And we are going to say my skeletal mesh and attach the component to the root. Now we will see in a second while we are doing this. And we're also going to use the damage box. It's going to be equal to create default sub object of the box component. There you go. The name of it is going to be the damage box, without the D. So simply damage box. So damage box. And again, same thing. So we need to say damage box dash greater than sign, attach the component to the root, but not this time. Instead, we are going to attach this to the sphere. So take the sphere, put it over here, put this over here as well, and attach it. And we see that it is complaining to the box component, which means over here, you see how we declare the box component. What you can do is remove it from here, and we can go right here and we can say include. So include components, pointer, no man, components, and dash, and it's going to be ubox, or let me just see the box component, ubox component, how to declare it. And I talked about this, how you can find this to know which one to import or include to know how to declare it. So let's go on the C++ API. I have issues talking. So over here we have components and it's box component without the U. So this is my mistake. So it's components, remove the slash, box component.h, and there you go. Which now is going to stop complaining. So components, and again we have components. So it's simply one time components, box component. Thank God it stopped complaining. Pay attention over here. Instead of using root to attach the skeletal mesh and the damage box, we're going to attach them to the sphere, but the sphere will be attached to the root component. So make sure that you change that. Now, before we proceed to create the blueprints out of our classes, let us just make sure that I didn't do an oopsie. So let's go over here, Control-Shift-B to build everything, or go under build and click on build solution, or Command-Shift-B on Mac, I believe. Let's hope that I didn't do an oopsie, and I did do an oopsie. So let's go over here and see what the issue is. So pickable weapon on line, so pickable weapon.h on line 21 and pickable weapon h line 32, 21 and 32. So what is the issue? So we have over here sphere component 21, also box component and sphere component. So I believe I know what is the issue. We do need to forward declare. So this is called forward declaration. We do need to say over here class u box component so that we can declare this, and class u sphere component so that we can declare this, because it was showing me that I had an error that I didn't. It says it found, or it didn't found the semicolon, but actually the semicolon is over here, which means we do need to declare the uSphere component and the box component. And this is called forward declaration. So I remembered now, it's called forward declaration. So instead of using here include, we can use it like this. Let's test it out now. Control-Shift-B to just compile everything and make sure that everything now is okay. And let's wait for it to compile. Hopefully my computer will be faster, and yes, it is. So here it is, build has succeeded. So there you go, we have our item base and we have our weapon. So here it is, our pickable weapon and item base. Let us now go back. Of course, in the next video, we'll start programming such as this attach item to. We will see how to incorporate it and explain everything what is going on. Also here for our weapon, we will now see what we did with all of this over here. But let's go inside of our blueprints. I'm going to right click over here and create a blueprint class. The first class that I'm going to inherit here inside of this search, it is going to be our pickable item base. So pickable, not the weapon. Make sure that you don't select the weapon, but the item base, because this one is going to be our shield. And I'm going to call it pickable shield underscore, not plus, but underscore BP. So again, this is our shield, and let's open it and let's drag it over here. So here is our default scene root. What I'm going to do is click on add component and filter for a sphere. And there you go. And I'm going to take this, actually, it's going to be a sphere collision. Not the sphere over here, but the sphere collision. So excuse me for that one. So take the sphere collision and attach it over here. So here is our sphere collision. Now, this is going to be our root component. And for it, I'm going to click on the add component and we're going to filter for the skeletal mesh. Here it is, and we want the skeletal mesh. So take the skeletal mesh, and over here for the skeletal mesh, for the actual mesh, click on the drop down list and select here the shield. There you go. This is our shield, which is going to be, well, you get the point. This is our shield. Now, what I'm going to do is take the sphere. So go over here, take the sphere, and for the sphere radius, so here for the sphere radius, instead of 32, we're going to set 70. There we go, because we want to detect collision and pick up this skeletal mesh, which is actually our shield. I'm also going to select the skeletal mesh and set the Z at 8.5. There we go. So it's kind of in the middle. Yeah. And I'm not going to touch anything else. Compile and save. This is our pickable shield. So let's go now and create the weapon. So right click and go under blueprint class, and now we are going to filter for the weapon. So here it is, pickable weapon. Now we want this. Click on select, and we are going to name it pickable hammer. So pickable hammer underscore BP for blueprint. And let's double click it. And over here we have already our sphere. Pay attention. So we have the root component, we have the sphere collision, skeletal mesh, and the damage box. You see, everything is over here ready for us. And why? Well, because we created over here. So here is our root component. We created a default sub-object. Pay attention, the name is root over here, and here it is our root component. And pay attention over here, create default text sphere. So if we go over here, it's my sphere, which is inherited. Basically, if I go back, so it's these names over here, my sphere, my skeletal mesh, and the damage box. And why is it showing here? I don't know why, but we saw that it is working, so don't worry about it. So here it is, damage box, my skeletal mesh, and my sphere. So what I'm going to do now is simply go select my skeletal mesh and click here on the drop down list in the details. Click on the drop down list and we're gonna go here under the mesh, and we also are gonna go, let me just find where is the transform. Yeah, here it is our transform. Because we do need to select the mesh and we do need to select, or actually just position the transform. So take over here the skeletal mesh and we're going to select the hammer. There you go, we have the hammer. Set the Y on the relative location to -33 just to move it a little bit forward as you saw. Now, when it comes to the sphere, so select the sphere, click on the drop down list for the sphere because we're going to change the shape. So it's 32, we're going to set it at 70. Now, the reason why I make it so big is because I want the player not to come, you know, that close to our component in order to get it, or that close to the weapon in order to get it. Instead, simply he can, you know, pass by, for example, here, and he can pick up the weapon. Now, what is this damage box? Let me just compile and save this, by the way. Now, the damage box is the one that we are going to use to detect damage when we punch or when we hit with the hammer. So we want to position it over here. So I'm going to take the damage box. Let's go over here, click on the drop down list. Let's go on the transform. So what I'm going to do is set the relative scale 0.4 on the X, 0.32 on the Y, and the Z is going to be 0.73. So you see it is being resized to the size approximately of the hammer over here. So there you go. And we are also going to reposition it. So set the Y at 26. So something like this can do. It's enough. You can also resize a little bit more if you want to. I'm satisfied with this. I'm not going to touch it anymore. So compile and save that. And there you go. Now, what we can do is we can go over here in our arena and we can drop them. So here is our shield. We can place it over here. Here is our hammer. We can place it over here. So we have the hammer. You see, here they are. We have the shield and the hammer. Let me just select them and maybe just position a little bit lower, something like this. There we go. So that our player can pick them up. So let me just save everything. And if I hit the play button, here they are. Here inside of our game. But now if we, you see, if we come close to them, you see what's happening. We cannot interact with them because we did not create the code that will help us do that. So let's do that in the next video and see how we can attach the items to the player and how we can use them then to attack the player or to attack the enemy. Fire here from Livestream.com. I will see you guys in the next video.